In this video, I'm going to discuss the concept of Lagrange's interpolation formula for the unequal intervals. Let x0, y0, x1, y1, x2, y2, and so on, xn, yn be n plus 1 tabular points of the function y is equal to f of x. So where x0, x1, x2 and so on xn are not necessarily equally spaced. Here x0, x1, x2 and so on xn need not be equal intervals of width. So let y of x be the nth degree polynomial such that y of x0 is equal to y0, y of x1 is equal to y1 and so on, y of xn. Here y0, y1 and so on yn are the points of y from the given data points, and y of x0, y of x1 and so on y of xn are obtained from the interpolating polynomial y of x. Let us consider the nth degree polynomial y of x. Let us consider the nth degree polynomial y of x. Y of x is equal to a0 into x minus x1 into x minus x2 and so on, x minus xn plus a1 into x minus x0, x minus x2 into and so on, x minus xn plus and so on, a2 into x minus x0, x minus x1 into and so on, x minus xn plus and so on, plus an into x minus x0, x minus x1, x minus x2 and so on, x minus xn minus 1. So this is the correct as equation. So what we assumed the nth degree polynomial, we can observe from this y of x here. In the first term, I have taken all the values of x, x1, x2, xn, but except x0 in the first term. But whereas in second term, I considered all the values of x except x1 here. So in the third term, I consider all the values of x but except x2 and so on. When you go to the nth term of the polynomial, I consider all the values of x like x0, x1 and so on, xn minus 1, but I did not consider xn here. So this is how I assumed the nth degree polynomial. So in this case, you have to find out the a0, a1, a2, and so on an, so that we'll get a Lagrange's interpolation formula. Now let us find out the a naught. To find a naught, take x is equal to x naught in equation 1. To find the value of a naught, we take x equal to x naught in equation 1. We get y of x naught is equal to a naught into wherever x you take x naught minus x1 into x naught minus x2 and so on, x naught minus xn plus 0. You can observe that in second term, when you take x equal to x naught minus x naught, that is 0, 0 into anything 0. So in third term also, when you take x equal to x naught, that becomes 0. When you take in the nth term also, n also becomes 0. So all other terms are 0 except a naught. But from the definition of interpolation, y of x naught is same as y naught. So therefore, a naught is equal to y naught by y naught by, so this term comes to the denominator of RHS, that is x naught minus x1 into x naught minus x2 and so on, x naught minus xn. So this is the value of a naught. Similarly, we can find out the value of a1 by taking x equal to x1 in equation 1. Take x is equal to x1 in equation 1. We get y of x1 is equal to a naught is 0 plus a1 into, you take wherever x you go for x1 minus x naught, x1 minus here x2 and so on, x1 minus xn, so further 0. So since y of x1 is equal to y1, therefore a1 is equal to y1 by x1 minus x naught, x1 minus x2 and so on, xn minus x1 minus here x1 minus xn. So this is a1. Similarly, we can find out a2 by taking x equal to x2. Therefore, we get y2 by x2 minus x0, x2 minus x1, next value is x2 minus x3 and so on, x2 minus xn. Similarly, we can write an also. Therefore, an is equal to yn divided by xn minus x0, xn minus x1 and so on, xn minus xn minus 1. So this is the value of a1. We found a0, a1, a2, a3 and so on, an. So these values you have to substitute in the nth degree polynomial. So we'll get a interpolation formula. Let us substitute a0, a1, a2, n in equation 1. We get y of x is equal to, I have to substitute a0 value here. So where a0 is equal to y0 by x0 minus x1, x0 minus x2 and so on, x0 minus xn. So let us substitute the a0 value, that is x minus x1, x minus x2, and so on, x minus xn divided by x naught minus x1, x naught minus x2 into and so on, x naught minus xn into y naught, plus let us substitute the value of a1. So that is x minus x naught, x minus x2, and so on, x minus xn divided by x1 minus x naught, x1 minus x2, and so on, x1 minus xn into y1, plus and so on. Let us substitute the value of an, that is x minus x naught into x minus x1 and so on, x minus xn minus 1 divided by xn minus x naught, xn minus x1 and so on, xn minus xn minus 1 into yn. So this formula is known as Lagrange's interpolation formula for the given data. To the problem, given the data of x and y, where x is equal to 5, 7, 11, 13, and 17, corresponding the value of y is equal to f of x are 150, 392, 1452, 2366, 5202. Here we need to find out f of 9. It means you have to find out y at x is equal to 9. Move to the solution. So here you can observe from the data, the points of x are not equally spaced, because you can observe that the difference of 7 minus 5, that is 2 here, 11 minus 7 is, that is 4, 13 minus 11 is 2, and 14 minus 13 is 4. So here h is not same, so therefore the given points of x are not equally spaced. So therefore we cannot apply the either Newton's forward interpolation formula or Newton's backward interpolation formula, because they are the method to solve to find the value of y only for equal intervals of width. So therefore we can evaluate the value of y at x equal to 9. So by using the Lagrange's interpolation formula. So this is one of the general formula to evaluate to estimate the value of y for any given x. Now let us assign the values of x here, where x naught is equal to 5, x1 is equal to 7, x2 is equal to 11, x3 is equal to 13, and x4 is equal to 17. Corresponding y values, y0 is equal to 150, y1 is equal to 392, y2 is equal to 1452, y3 is equal to 2366, and y4 is equal to 5202. Now let us write the Lagrange's formula for the given data points. We have Lagrange's interpolation formula, that is y of x is equal to for the first term of the interpolation formula, we have to exclude the x naught in the numerator. That can be written as x minus x1 into x minus x2, x minus x3 into x minus x4. Only the up to x4 you have to write, divided by, you have to subtract from the x naught minus x1, x naught minus x2, x naught minus x3, x naught minus x4 into y naught. So this is the first term of the Lagrange's formula. So similarly, we can write the second term plus x minus x naught into x minus x2 should write here, not x1. Should not subtract the x1 values from the x here. And x minus x3 into x minus x4 divided by, you have to subtract from the x1 value x1 minus x0, x1 minus x2, x1 minus x3 into x1 minus x4 into y1 plus, let us add the third term, x minus x0 into x minus x1 should not subtract the x1 from x2 here, that is x minus x3 should write here x minus x4 divided by x2 minus x0, x2 minus x1, x2 minus x3 here, and x2 minus x4 into y2 plus x minus x0 into x minus x1, x minus x2 into x minus x4 should write here, divided by, you have to subtract from the x3, x3 minus x0, x3 minus x1, x3 minus x2, x3 minus x4 into y3 plus, should write the last term here, so x minus x0, x minus x1, x minus x2, x minus x3. In the denominator you have to subtract from the x4, that is x4 minus x0, x4 minus x1, x4 minus x2, and x4 minus x3 into y4. So these are the given data points. According to that, so we have established the Lagrange's interpolation formula. Now let us substitute the values of x0, x1, x2, x3, x4, and y0, y1, y2, y3, and y4, and x values here. X is here 9. X is 9. You have to substitute all the values in the Lagrange's interpolation formula. Therefore, we get y of 9 or f of 9 is equal to, where x is 9, that is 9 minus 7, x1 is 7, into 9 minus 11, where x2 is 11, into 9 minus 13, into 9 minus 17, divided by, you have to subtract from the value x0. X0 is here 5. 5 minus 7, 5 minus 11, 5 minus 13, 5 minus 17 into y0, where y0 is equal to 150 plus, here you have to move to second term of the Lagrange formula. You have to subtract from the point 9 here, where x is 9, 9 minus 5, 9 minus 11, 9 minus 13, 9 minus 17 divided by, it was separate from the point here 7, that is 7 minus 5, 7 minus 11, then 7 minus 13 into 7 minus 17 into y1, where y1 is equal to 392, plus, then here you have to subtract from the again 9, that is 9 minus 5 into 9 minus 7, 9 minus 13 into 9 minus 17 divided by, to subtract from the next value here, that is 11. So 11 minus 5, 11 minus 7 into 11 minus 13 into 11 minus 17 into, should write no why not y1 y2 value, y2 is here 1452, 1452 plus, then you should write the, you have to subtract from the 9 again, 9 minus 5, 9 minus 7, 9 minus 11 into 9 minus 17. You have to subtract from the 13 now, 13 minus 5, 13 minus 7, 13 minus 11 into 13 minus 17 into next value here 2366, y3 values 2366 plus, should write here 9 minus 5 into 9 minus 7 into 9 minus 11 into 9 minus 13, then you have to subtract from the point 17, 17 minus 5, 17 minus 7 into 17 minus 11 to 17 minus 13 into 5202. So this implies y of 9 is equal to 2 into minus 4 into minus 8 divided by minus 2 into minus 6 minus 8 into minus 12 into 150. This is first term. The next term we have 4 into minus 2 minus 4 into minus 8 divided by 2 into minus 4 minus 6 into minus 10 into 392 plus, so let us write the third term. So 4 into 2 into minus 4 into minus 8 divided by 6 into 4 into minus 2 into minus 6 into 1452 plus 4 into 2 into minus 2 into minus 8 divided by 8 into 6 into 2 into minus 4 into 2366 plus, let us write last term, plus 4 into 2 into minus 2 into minus 4 divided by 12 into 10 into 6 into 4 into 5202. So this is equal to minus 16.6 plus 209.067 plus 1290.67 minus 788.66 plus 115.6. This is equal to 810.077. So therefore f of 9 value is 810.077. So this is the value of y at x equal to 9.